Welcome to the 18th video in the playlist Top Interview 150 Leetcode. In this video, we are going to be solving the 18th problem from this list, which is called integer to Roman. In this problem, we have been given 7 different symbols, which represent a corresponding value, and we have been given an integer num. We have to convert this integer to its Roman numeral representation. One thing to notice in this question is that we have a constant from 1 to 3999, so this makes the question a little bit simpler. And I am going to reuse some of the approach I explained from the last problem. So let me just remove what I don't need and keep this here. Now in this problem, since the constraint is from 1 to 3999, one thing we can do is that for every possible thousands, hundredth, tens or a ones value, we can hard code it to an array. So for example, thousands would be 0,000, 1,000, 2,000 and 3,000. Now notice that we don't need to go to 4,000s for this array because the constant is fixed at 3999. Similarly, for hundreds, we can go from 0, to 100, 200, 300, and then 400, which is CD, 500, 600, 700, 800, and then 900 CM, and then that's it because we already have 1,000 here. Similarly, we can make an array for tens. This would be 0 tens, 1 tens, 20, 30, 40, 50, 60, 70, 80, 90, and 100 is already there. And then at the end, we have the ones values. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So what we can do is if we want to make any number, let's say we want to make 3960. So let's say num is 3960. Now to be able to get the Roman representation for 3960, what we can do is we can extract the 1000 digit, which is 3, and check what is the representation for 3000 in this thousands array. So this will be MMM. Then we can take out the 100 digit and take out the representation for 900 in this array. So 900 is CM. So CM. Then we can take out the 10th digit and see what is the value for 60 in tens. So 60 is LX. And finally, we can take out the first digit and see what is the value for 0 in ones array, and this is empty. So this will be empty. So this is our 3960 representation in Roman. So this is my approach, that we have to hard code the values for thousands, hundreds, tens, and ones, and just extract the corresponding unit from the number. So let's write code for this. So I'm going to declare the same arrays as this. C, CC, 200, 300, 400, 500, 600, 700, 800, 900. And we are going to do it for tens. Similarly, the code is very simple, but it's just repeatable for this question. So let's go through this exercise. We have 10, we have 20, we have 30, we have 40, we have 50, we have 60, we have 70, we have 80, and we have 90. Let's repeat this one more time with the ones array. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now the final part where we are extracting the corresponding digits from the number and mapping it to the array. So to be able to do that, what we can do is we can do a return now, and we can do a lookup. So if we want to look up for 3 in the thousands array, what we can do is we can say thousands of, so you need this correct spelling, and then whatever the number we have, so num, and divide it by 1000. So in this case, for any number which is 1950, this will return 1. For 2000 number, this will return 2. So it will go to the correct corresponding index. For any number less than 1000, this will go to 0th index and it will be empty. Plus, we can go to hundreds array, and here first we need to extract 960 and then extract 9. So let's extract 960. So if we do a mod with 1000, we will get 960, and then we have to divide this by 100. So we will get 9. Let's do this for tens. So we have to get rid of first two digits. So let's mod it by 100 and then divide it by 10. Finally, we have to do the final mod. So we do some mod 10 to get the final digit. And if we run this code, we should be able to pass the test cases. We are able to pass the test cases and get an accepted solution. Another thing we can do here is that we can take all the values and put it in a values array in a sorted order. And for every value in that array, we also have a symbols array. And if we don't want to hard code these values, what we can do is we can iterate over the values array. And until we have a value in the values array, which can be subtracted from the number, we keep subtracting that value and add that symbol for the corresponding value to the result. So similarly, if you take the same example, 3960. So let's build the values array first. Our values array would be 1, 4, 5, 9, 10, 40, 50, 90, 100, 400, 500, 900, and 1000. This will be the values array. Now what we are saying is we set the cursor to the greatest value in the values array, which is here. Now what we do is if we are able to subtract this value from this, why we are able to do that? So while value is subtractable, add the corresponding symbol to result. So here we can subtract 1000 from 3960. So 3960 becomes 2960, and we append the symbol for 1000, which is m, to the result. Again 2960 becomes 1960. We again append the symbol of 1000 to the result. Again 1960 becomes 960, and we again append the symbol of 1000 to the result. So if you notice, this is essentially the same thing we are doing, which we were doing here in the hard-coded way, but this approach will work for any number instead of just this constant 1 to 3999. Now once we reach 960, we won't be able to subtract 1000 from 960 because 1000 is greater than 960. So we have to move our cursor back. We move our cursor to 900. So the moment we move our cursor to 900, the symbol for 900 is CM. So if we subtract 900 from this becomes 60, and we add symbol, which is the corresponding symbol for 900, to our result. Now 900 is again greater than 60, so we cannot subtract it again. We move our symbol back. 500 is still greater, move our symbol back. 400 is still greater, move our symbol back, and we keep moving back until we reach to 50. Now we can reduce 50 from this, so this becomes 10, and then we add the 50 symbol, which is L, and then we cannot subtract 50 again, so we keep moving the cursor back. Finally we reach at 10, and we subtract the value 10 from this becomes 0, and we append the value x to the result. And the moment the value reaches 0, we have successfully converted the integer to the Roman numeral. So if we want to write code for this, we first have to create the values array. So integer values is 1, 4, 5, 9, 10, 40, 50, 90, 100, 400, 500, 900, 1000. Similarly, we create string array called symbols, and for every value in this value array, we add the corresponding symbol here. So I, IB, B, IX, X, and then for 40, we add XL, so XL, then add L, then add 90, which is XC, so XC, then add C, then add 400, which is CD, so CD, then 500, which is D, and then CM for 900 and M. So CM for 900 and M. Now, I remember I said earlier that this approach can be used to convert any integer to Roman numeral, but you will need further values for the values and the symbols array. So let's write code for this. Now I said we have to set our cursor to the final value in the values array. So let's set our cursor there. So for int I is equal to values dot length minus 1, I should be greater than equal to 0, and I minus minus. So while we are able to subtract the current value from the nums. So this means nums is greater than values of I. So if nums is greater than values of I, then only we can subtract values from the nums. So what we can do is we can reduce the value from nums and append this corresponding symbol to the result. So let's have a string builder to store the result, and store result dot append symbols of I. Finally, return result dot to string. Here, one thing to note is that I should be greater than equal to 0 and num should be greater than 0. Num. And here this should be greater than equal to run the test cases, and we are able to run all the test cases. And if we go ahead and submit the solution, we are able to get an accepted solution. So in this video, we tried to solve the problem integer to Roman. In the next video, we will be solving the 19th problem from Leetcode Top Interview 150 list.